Okay everyone, here we are looking at the back of the exoskeleton, and here is that miniature power unit. And the rest of this video, the majority of the rest of this video will be about how I put this together. And it's just a temporary unit, basically put together just to test raising and lowering the chest armor. It runs off this 12-volt battery, so it's actually independent, as opposed to the original power unit that I built right here, which runs on that AC motor, 3 horsepower AC motor, which I have to plug in. And so this is the first step toward building a power unit which is completely independent of anything else and just stays on the exoskeleton. So a question might be, can this run the entire exoskeleton? The answer is no, because this motor, well, two main reasons. One, the motor has too low of a volume. The oil is pumped too slowly. So in the larger cylinders, they would move so slowly, they would extend and retract so slowly that it would be impractical. And secondly, the motor, the motor, doesn't have enough horsepower when the cylinders are under heavy load. So if I'm trying to lift something heavy, then the pressure builds in the system and the pump can no longer rotate, and the motor can no longer rotate the pump. It doesn't have enough horsepower. So it would stall out or burn up. It's almost like if you've ever used a manual bicycle pump to pump up a bicycle tire. The closer the tire gets to full and the higher the pressure is, the harder it is to pump up and pump in more air. It's the same thing with a hydraulic pump. So now let me show you this in action as I raise and lower the chest armor. You can even watch the pressure rise in the gauge. And I'll lower it. Now let me show you the cylinder. Here it is, and here we go. See the chest armor rising up. Okay, so it does work. I just have to make a bigger version to run the entire exoskeleton, and I'm working on that. Alright everyone, I have the mini power unit for the chest armor cylinder put together, and I haven't done the wiring yet. I'm about to do that, but I'll just give you a quick look at it. Here's the motor, and the pump gear is in there. The reservoir is over here. This is the solenoid valve, and the wires for the solenoid are here. Of course, here's the manifold. There's the terminal block where I'll be attaching all the wires. The pressure relief valve attached to this homemade manifold, and the pressure gauge, just so I could read what pressure everything is. Alright, ladies and gentlemen, right now I'm going to talk about the individual components that I'm using to build the small power unit. Right here is a miniature hydraulic pump and reservoir system, or unit. It's actually from, I think, a Ford Mustang for the convertible top. And this is the electric motor, 12 volt DC. Here's the pump in the center, and then this is the reservoir. So the pump is going to go on this plate, on these studs like this. And this is just a temporary power unit. This is just for just to demonstrate the chest armor moving up and down, because the final power unit is actually going to be it's going to be a tri pump. So there's going to be 3 pumps in one unit, almost like how some electric cars are tri-motor or dual motor, like Teslas or Rivians, where they have 2 or 3 motors. This is going to have 3 pumps. So the pump is going to be here, and on this bracket which will sit in here. Let's move the pump out of the way for now. The solenoid will sit on top of that, like this. And this solenoid is different from the ones that I'm using on the exoskeleton, which I'll explain. Alright everyone, I'm going to talk a little bit about the solenoid that I'll be using for the small power unit. Here it is right here, and to compare it to the main solenoids, which I have here, these are bigger. And the reason for that is, if you notice here, this is the coil. It's an electric coil, which basically creates an electromagnet. The solenoid valve is actually inside this body, and it diverts fluid to the various ports. If you look here, this is a coil, and this over here is another coil. So in other words, this is only half of what that is. So it's like this, and then imagine there's a second one right here, and they're attached in the middle. And not only is it different in the ways that I explained, but it's different with these ports. I think these are metric or something, I'm not sure. Because this body was, I think it was made in China, and I think they use metric. So I can't identify them. So basically there was a problem. Fortunately, they came with 4 of these fittings to fit inside. Unfortunately, they didn't have these hose barbs, because I'm using this light gauge hose, which is, it works to 225 psi. And in order to adapt the fitting that goes in here to the hose barb, I had to weld the hose barb end onto this. I had to cut off what was here and weld this on. And I'll show you a picture of what that looked like. So with that done, and I couldn't just buy a hose barb with these threads because I have no idea what these threads are. I still haven't figured it out. So I actually had to make 4 of those, well, 3 of these, and then one of them I had to weld this JIC fitting on, so that I could screw this on, and I had to weld some new threads on this so that I could screw that on. So it was a circus, basically, trying to get this to work. And what I also have is this. This is a pressure relief valve, but it's not designed for hydraulic cylinders. It's designed for a water heater, a residential water heater. So it only goes from I think 25 psi to 175 psi. And the reason I chose this one is because I want it to be a very low pressure, because the cylinder for the, because the hoses that I'm using are of low pressure, so I don't want them to rupture. This is a low pressure system, so the exoskeleton is going to have a high pressure system for the arms and legs and all that to get that super strength, and then it's going to have a low pressure system, which will be for the chest armor and maybe for the hands, fingers, etc. I decided to weld studs onto here, which might have turned out to be a bad idea depending on how well they line up. Okay, I have the pump on. Now, install that. And I will now add the solenoid. This right here is a manifold that I made so that I could screw in the pressure relief valve, as well as screw in something to tell me what the system pressure is. And I'm just loosely screwing them in right now. I'm actually going to use thread sealant because these are pipe threads, and I hate pipe threads, to tell you the truth, because they, after you screw them on, from my experience, you screw them on, if you unscrew something and then try to screw it back on, it's gonna leak, especially if you don't use pipe sealant, pipe thread sealant. So that's what I'm gonna use. But these came with pipe threads. Like I said, this is for a water heater, so of course this is gonna have pipe threads. So this gets screwed on right here, and then after that's installed, after all the mechanical stuff is installed, what I have to do is use this terminal strip to connect, to do all the wiring. So the way it's going to work, the way this solenoid works is it's two position. So in other words, if there's no electricity going to this, fluid will automatically flow to the A port, or maybe to the B port, however they set it up at the factory. Then when electricity is sent to this, the solenoid will activate, and then it'll switch and the fluid will go to the opposite port. And then when the electricity is turned off again, it'll return to its original setting and flow back through A. So depending on whether there's electricity or not, it'll go to A or B. And if it's flowing to A, the fluid that comes out of the cylinder to B will go back into the tank. So the way I'm going to use this is that the electrical switch will be connected to the pump and the battery. So when I press the first button, it won't activate the solenoid, and the fluid will go to one side of the cylinder and out the other back to the tank. Then when I press the other button, which will be wired to the solenoid and the pump, it'll cause the pump it'll cause the solenoid to activate, which will send fluid to the other side of the cylinder, basically reversing the flow on demand. So let me finish setting this up, try to get this done. Alright, so that's basically how all the fittings go together. I have to connect the hoses and all that kind of stuff. To do the wiring, the motor, I had to split it into two leads, both the positive and the negative, because in order to get the solenoid to work when I'm pressing one button, I have to wire the solenoid in parallel to one of the circuits and leave the solenoid out in the other circuit. So the solenoid will be in parallel to the motor in one circuit, and in the other circuit, basically with the other switch, there will be no solenoid involved at all. Alright everyone, unfortunately I have to admit to a blunder, a big blunder that I made. The purpose of this was to, here are the switches. The purpose was for when I press one switch, the pump alone will activate. When I press the second switch, the pump and the solenoid will activate. So I wired it where I thought they were on two separate circuits, but if you remember how I split the leads from the motor and the batteries to connect them to the two different switches, it turns out that that actually allowed the circuits to share electricity. So when I press one button, you could hear the motor and you could see the light on the solenoid activating. When I press the second button, the exact same thing happens. So it turns out my circuit was incorrect, and I had to take a break, and about 10 minutes later it occurred to me. I just stopped thinking about it, went to do something else, and my subconscious mind told me what the answer was. I have to wire it so that one circuit, one switch is connected to the motor, and the second switch is solenoid only. So I could simplify the wiring, which is really nice. And that seems super obvious now, but it wasn't obvious 2 hours ago when I made the first video clip. Okay everyone, I got it figured out. So I finally switched it. When I press this button, it's just the motor, the pump, and when I press this button, it's just the solenoid. And when I press them both, I have both. Seems like sometimes there's a little delay with the motor though. I don't know if that's the switch or the motor itself. But it's a little inconvenient that I have to press both buttons at the same time. Maybe there is a circuit where I wouldn't have to do that. And there's probably someone watching this, maybe you, who knows of a circuit that would do that. I could probably figure it out if I spend more time with it. But, or if I was an electrical engineer, which I'm not. So, I'm going to have to deal with this for now. And it doesn't really bother me that much because this miniature power unit is only temporary anyways. So, I guess for now it's okay. And I'm going to mount it to the back of the exoskeleton. Now, after all that detail, let's watch the results in action. As I like to say, I hope you always find something to look forward to, and I'll see you in the future.